as we work with linear functions and linear equations in this Algebra II course, it's a good idea to review some of the key characteristics of lines. In this video, we are going to review slope, two of the more popular forms of lines, and what does it mean for lines to be parallel or perpendicular. So reviewing slope is a measurement of the steepness of a line. Every line that we come across will have a calculable slope except for vertical lines. Vertical lines have a slope that is undefined. We have a variety of strategies for determining the slope of a line and a number of different representations for that slope. Some people like to think of the slope as the change in y over the change in x. Some people like to think about slope as the difference in the y coordinates divided by the difference in the x coordinates. And some people like to think about slope as rise over run. Regardless of your representation, all three of these different formulas will all end up with the same value for the slope of the line. In order to determine the slope of any line that you're given, you're going to need to start by identifying two of the points that are on the line. When you identify the 2 points that are on that line, you try to identify them in such a way that they'd be very simple to work with. This example we have here is a perfect example of that. I'm going to first start by identifying this point right here on the y-axis, our y-intercept of the line. We're also going to identify this point down here as our second point. Moving from left to right, we calculate the change in y and the change in x. We see how far up or down do we need to go in order to get from one point to the next, and then we see how far to the right we had to go. I personally prefer always going to the right, but you are able to calculate the slope going right to left as opposed to left to right. But if you go right to left, you have to worry about negative x values. In order to limit the amount of negativity that we have to worry about, we're going to focus on going left to right. So from this leftmost point, which is at the position -10, -7, to this point right here, which is at the position 0, 2, we calculate our slope by drawing a slope triangle, where we go up from the one point and then over. And we calculate the lengths of those two distances and use those to help us figure out our slope. So going up, we're moving up from -7 all the way up to 2. That's an increase of 9. Then we move from -10 all the way over to 0. That's an increase of 10. The slope formula and our different slope strategies end with us thinking of this slope as a fraction, where 9 is the change in y and 10 is the change in x. When we work with the equations of lines, there's two different forms for the equation of a line that are a little bit more popular than the others. Sure, there's other forms out there like standard form, but the slope-intercept form and the point-slope form are the two most common. Both of the forms, you'll notice, have slope in their name. That requires us to calculate the slope of the line given the information in the graph. After we identify the slope, these two formulas require that we use different information. Slope-intercept form requires that we use the intercept. Point-slope form requires that we use any point on the line. Because the second one requires that we use any point on the line, it is a little more versatile and can be used in more situations, but as you can see from the two example formula, it's also a little bit more complicated. So in those situations where we can readily identify the the intercept, like we can here, 0, 6, it might be in our advantage to jump right to that intercept and not have to worry about any other points. But for the purposes of this exercise, we'll try it a couple of different ways. We need a second point in order to calculate our slope. I identified the point here at 4, 3 as a good spot. I draw my slope triangle. I'm going down and over this time. Since I went down, this will be -3. Since I went over to the right, that'll be 4. And I have a slope of -3 over 4. Because I have that slope, and because I have the y-intercept, I could jump directly to the slope-intercept form. The slope-intercept form requires that I make the slope of the line the coefficient of x, and I finish with the intercept of the line. In the event that I didn't have the intercept, and I needed to use the point-slope form, I can do that with the other point that I identified. We subtract the y-coordinate, we use the slope again, and on the inside of the parentheses, we subtract the x-coordinate. A little bit of careful algebra would reveal that the answer, or I shouldn't say the answer, the simplified version of this equation is exactly the same as its slope-intercept form. But again, the point-slope form offers us a little bit more versatility in terms of writing it because we didn't necessarily have to use the intercept. But the process was the same. We found the slope and we used the slope that we had. Lastly, we want to review the definitions for parallel and perpendicular lines. Here I have an example of both cases. The green line is parallel to the black line. You'll notice two different things. It has the same slope as the black line, but it has different y-intercepts. We want to make sure it doesn't have the same y-intercept, because if it had the same y-intercept, then it would be sitting right on top of the black line. But because they have different y-intercepts and the same slope, they remain parallel to each other. Contrast that to the red line, which is perpendicular to the black line. A lot of people think that the perpendicular is just the opposite slope, that it's going the other direction. Unfortunately, it's a little bit more complicated than that. It's actually the opposite reciprocal. So whatever your slope was, in this case for the black line, whatever our slope is for the black line, we want the opposite reciprocal of that as the slope for the red line. Calculating all of that so you can see what it looks like. If I use this point down here at -10, -7, I also notice that my black line goes through the origin. That means I'm going to have a slope for the black line of 7/10. A very similar calculation for the green line, starting here at -10, -2, comparing that to its y-intercept of 0,5, I could count that slope triangle and see that my slope is the same. Contrast that one more time to the red line, where I could use this point down here as my guide. This is the point -7, -10. I again see that the red line goes through the intercept. I can look at this slope triangle, and I see that my slope is -10/7. Exactly the opposite reciprocal that I was looking for from the black and the green lines.